Okay, we are going to start out this lesson with talking about standard form. We're going to be talking about standard form in a few different capacities for Math 8. We are going to be looking at what standard form is, like how the format of the equation is, and what is necessary for that format. And then we are going to look at a problem graphed in standard form using a table of values. And then we'll also look at a graph where we can just use intercepts to like graph our equation. And last but not least, there's going to be a bonus video after this. So the fourth video you don't necessarily need to watch unless you truly need it to understand what's going on, or if you want to do it for our day 2 work when you're actually doing some of the real word problems and stuff like that. So standard form. Standard form is just a different format of a linear equation. We already know slope-intercept form, where we have y equals mx plus b, where we can easily find the slope and the y-intercept. But standard form takes all of this and sets everything, all of this stuff here, this mx, essentially comes out in front and becomes this new format where we have ax plus by equals c. Now that's a super simplified concept. I'm not actually saying that mx actually comes out in front in quite the way that you're like possibly imagining, because a, b, and c have certain parameters that you have to like sort of hit when it comes to actually formatting an equation in standard form. Some of those parameters are this. This letter A, this number that essentially replaces that A value, that coefficient that stands right here, this coefficient has to be a positive whole number. So you cannot have fractions here. You cannot have a negative number here. You cannot have a square root here. You cannot have decimals here. It needs to be a number like 1, 2, 3, 4, 5. If there is a 0 here, you don't have a linear equation, first of all. I guess you do have a linear equation. It's just going to be a horizontal line. But what you don't have is you cannot have a fraction here. All of the numbers, in fact, B, C, and A, are not going to be fractions. You will not have fractions whatsoever within this format. This B and this C have the same parameters that you have to hit. These can be positive or negative numbers, but positive or negative, but they have to still be like that whole number. So you're looking at integers here. So we're looking at those numbers like negative 20 or up to, or like any numbers that are negative infinity to positive infinity, but are numbers that you essentially can count. So like negative 20 is a solid number, negative 2 is a solid number, but so is 15, or so is a million. Those are all numbers that we can put in for B or C. What numbers we can't is like negative 1/2 or negative 2.3. We can't have decimals or fractions in any of these coefficients. So let's look at an example problem of what a standard form equation would look like. I think that's my bad marker. Sorry. Standard form equation could look like this. 5x minus 3y equals, let's say 10. So this is an example of a standard form equation. This is one that's a little bit more difficult than what we're really going to be looking into a lot in 8th grade math. This is more of an algebra one, because this 3 and this 10 aren't going to be playing very nicely if we ever have to find intercepts. So if we ever want to find where the x or y intercepts are, this negative 3 is not going to play very nicely. Regardless, 5x minus 3y equals 10 is very much a standard form problem. So if I ever asked you, what is the A value? What is the B value? What is the C value? You could tell me. So A value is the coefficient that's connected to the x. So we could say A is equal to 5. We could then say B is equal to the coefficient that is in front of y. And notice the base equation has a plus sign here. So because this has a minus sign, that means our B is a negative 3. Okay, so we have to make sure that 3 is there. So we have to say plus a negative, so that way it makes it really clear that that B is negative. And our C is 10. An example of a not or an equation not written in linear or in standard form could look something like this. One half x minus 2/3 y is equal to 6. So while this c here is a whole number, this 1/2 and this negative 2/3 is not so hot. This is not okay. What we essentially would need to do is we need to manipulate this equation by multiplying by a common denominator of both of these fractions. So we could multiply this by 6 and this by 6. And if we multiply those by 6, we also have to multiply this by 6. And we could format this so that way we actually have whole numbers out in front. Now, again, that's a little bit beyond what we need to do for 8th grade math. However, I think it's still something that you could potentially do. So we're going to see what it looks like. So if I multiply this by 6 and this by 6, remember, whatever I do to one side, I have to do to the other. I'm multiplying by 6 because 2 times 3 equals 6, and that's a common factor for both of these, or it's a common multiple for both of these fractions. So 6 times 1/2 would give me 3x. So I'm just essentially doing the distributive property here. 6 times 2/3. So what's 2/3 of 6? That would be 4y. I'm still going to bring that subtraction sign down because this 4 is causing that to be negative, and that's equal to 36. So now this is written in standard form. If this number up here were negative, I'd have to maybe multiply by a -6 to be able to turn this positive, because again, this a coefficient needs to not only be an integer, but it needs to be a positive integer. So I can only have numbers that I can count on my fingers and my toes. So like 1, 2, 3, 4, 5, 6 up to positive infinity. Whereas this could be a number that is an integer from -infinity to positive infinity for those. All right, so I hope that helped you understand what standard form is. We're going to see it applied in various graphs situations and see how we can sort of manipulate this. Thanks for watching. Bye.